from the scratch. You have only the basic elements which you think came out of the Big Bang. Now, for you, in order to understand the complexity of an hydrogen, you need to define every single steps need to be taken from the explosion to the level of building the hydrogen. So, and if you define them, and if you do experiment that you can actually show that works, that can give you hydrogen, then I will say yeah. But you can't just go and actually get some, ready component and then say, you know what, look at the car. It's not that complex. After all, it's just 4 tires and a wheel. See, if you have a tire, it runs. Yes, the tires are the basic component of the car, but that doesn't mean that the car is just made of tires. So the same thing that what you observe in those elements is that might be more complexity beyond your observation.
Okay, well, back to your original claim here that a single hydrogen atom is more complex than any man-made object. To me, is silly. It's just ridiculous, and you should be able to see that by just realizing that any man-made object is made of trillions and trillions and trillions of atoms. So naturally, something made of all of those atoms is going to be more complex than a single atom. That's just common sense, rational thinking, and if you can't see that, then I can't help you with it. Now, to your idea about number of steps as a measure of complexity, I mean, that sounds like it might be a useful kind of measure of complexity. What you're imagining is, what if we assembled a complex object, subatomic particle by subatomic particle, one by one. But wouldn't that just be equal to the number of subatomic particles in the object? In other words, let's say I have an object composed of 3 parts, A, B, and C. Step number 1 is pick out part A. So I do that. That's step 1. Step 2, add part B to part A. Step 3, add part C to parts A and B. How many steps do I have? I have 3 steps. How many parts do I have? I have 3 parts. So it would seem to me that the number of steps would be equal to the number of parts if you were assembling by a step-by-step manipulation of the parts of any complex object. Seems like that would always work. So I don't know that you would get a different answer by considering number of steps compared to number of parts.
First of all, it's amazing that you get it, in a way that you're saying that man-made complex objects actually already contain atoms, so that's why atom cannot be complex. And I'm talking about the complexity added by human being. So I'm not talking about the complexity already exists in the nature. When I talk about man-made complex objects, I'm talking about the complexity added by human being to that objects. So I'm not giving credit to human being because of the complexity in atoms, because that's not the complexity added by human being. It would be nonsense for me to give credit to human being for that one. Now, my point is that I will try to compare the complexity added by human being to the man-made complex object to the complexity exists in an atom. So in this case, what I define in a hydrogen, when you look at hydrogen, I don't think that you can just equal the number of component to the to the level of complexity, because you can get those components and process them. Let's say you heat them to a certain level, you put them in a water to certain, you freeze them. So now all of them, you're processing the very same component to, in order to use and to build up a complex object. That's what when you try to build up, let's say, computer, build up other objects. So it's not just really just bringing and putting them together. You are processing them ultimately, and that process, the way that you process, the step that you take might give you different level of complexity. So my point is that whatever the manual that you come up with to make the objects, you need to write a manual, and you need to, if the objects, because we only have a simple, we will only give you the simple basic elements, nothing else. Now, if you need to have some complex element to build up hydrogen, then you need to make those complex elements first from this basic element, then you can build up hydrogen. You cannot just go and actually, say, okay, now I need just actually one electron, one proton, and let's give me electron, proton, I will build it up. No, you need to go and build up electron. You need to go and build up proton. So that's what I mean. That's when, the complexity in an atom. So for that reason, I will say that if, I think it's really, we should just go and ask an expert and say, okay, based on the knowledge that you have, what would you say about the complexity in a hydrogen atom? We will come and share with our audience.
Well, before you ask an expert, you have to have a sensible question. So you need to formulate your question in a comprehensible way. I don't think you've done that yet. I think that you're not really talking here about the complexity of an object. From what you just said, you seem to be talking about something different. The complexity of the production process. In other words, the number of steps required to produce an object by intelligent agents acting on the object, not the number of parts of the object. Those are two different things. So, we can talk about that. If we took the Large Hadron Collider in France and Switzerland, we could actually count the number of steps that it took to produce that thing. It would be an enormous number. But in theory, that is possible. Okay. Now, to produce a hydrogen atom, I don't know that we can assess that. I'm going to guess, though, that scientists may have already done this, that they may have taken a proton that's existing by itself and brought an electron near the proton and produced a hydrogen atom. I'm going to guess that that has already happened. Perhaps by using an accelerator. Let's suppose you shoot an electron at a proton, and the two combine, and you get a hydrogen atom. In the early universe, the energy required to make that happen was there. We know that the primordial packet, we'll call it, was very hot, very dense. There was a lot of energy in there, and that these combinations would have occurred in that high energy environment. And so what scientists do is they merely try to duplicate what happened in the early universe and produce a hydrogen atom in that way.
Okay, I think that's if that was perhaps a confusion in our understanding of complexity. That's what you said might have, and I think for us, what we really should care about it is not the components and the number of the parts of the object. That should not be the base for our definition when we define complexity.